Welcome to Easy Elimo Learning Simplified. My name is Eric. I'll be taking you through this topic, decimals. And for this lesson, we'll be looking at a continuation of recurring decimals called recurring decimals 2. So for this lesson, majorly we'll be looking at recurring decimals and how to convert the recurring decimals to fractions, and especially for mixed decimals or mixed numbers, the decimals that are having the whole number part and the decimal part. So that is what we are going to cover as displayed on the screen. So we have recurring decimals of mixed numbers and basically how you convert them back to fractions, just as we had seen in the previous slide when we were talking about uh, recurring decimals as well. So after the lesson, we'll be able to give you some assignments to help you check your understanding and also just to help you gauge your understanding of the concept, and as well just to enable you practice, on what you've covered during this lesson. So we have the first one here. You can see a mixed number here that has got the whole number part as 2 and the decimal part, that is 0.67. And you can see from our previous discussion, you have a dot on top of 7. You can see only 7 recurs. So as we said previously, you are supposed to let the fraction be a letter like P, for example. So our decimal here is the fraction represented by this decimal here is P. So P is equals to, so what I'm going to do is I'm going to omit these two. This is the whole number part, when you talk about the mixed numbers. So this is the whole number part and then the fraction part. So I'm only going to focus on the fraction part only. Then later on, I will add the whole number part. So I have P is equals to 0.677, and 7 is the one that is recurring, So I will multiply both sides by 10 until I have a pattern after the decimal point being the same in at least 2 lines. So 10p is equals to 6.7777. The 2 lines are having different patterns for decimal points. So I'll have to continue. So 100p is equals to 67.7777. So you can see this pattern and the other pattern, they're the same. So you can be able to subtract the two. Remember, after you've gotten a pattern after the decimal point being the same in at least 2 cases, you simply stop and then you subtract the 2 cases. So as you subtract, you remember to subtract the smaller number from the larger number. Like in this case, I'll be subtracting 10 from 100. So 100p, and the other side I have 6.7777, So if you subtract, this is 0, 0, 0. Here is where I have 1, 6. And here I have 90p. So if you divide both sides by 90, then you can see now we have our p is going to be 61 over 90, and that is the end. That is the simplest form of that fraction. So take note that there is part of it that we omitted, 2 here. So you'll have to add it. So you now write 2.67, the dot on top of 7 should be equal to 2 and 61 over 90. So don't forget to add the whole number part. Once you convert the decimal part to a fraction, remember to add the whole number part. It is very easy to forget that part. So we have another one here. Again, you do the same thing. So let me use Q now. So the fraction is Q. So here there is a dot on top of 2 and a dot on top of 5, meaning the entire pattern here, 215, is repeated. So I will omit the whole number part first. I will just add it later on once I get the fraction. So this is 0.215, 215. So the pattern repeats itself that way. So I'm only using the first 2 digits, the first 6 digits. So again, you'll multiply by 10 on both sides until when you have a pattern of the decimal point the same in at least 2 cases. So 10q is equals to 2.15 2152. Those are 6. So you continue again, 100Q, 21.5215. So 21521. I'm only interested in 6. So 21521. So if you start from this end, you see the pattern is still maintained. 215, 215, 21. The next one should be 5, but now I'm stopping at the 6th digit. So we can't find any two cases where the pattern of the decimal point is the same. So I'll continue to the next one. 1000Q is 215.215215. Remember to maintain the number of digits of the decimal point. So you see, this pattern here is the same as the previous one. The pattern after the decimal point is the same. 215, 215, 215, 215 in both cases. So you subtract the two. So you have 1Q. This one is just Q up there, but no, usually if the coefficient is not written, that number before the letter, if it's not written, usually is taken to be 1. So 1Q. So this is equals to 0.215215. So if you subtract, this is 0, 0, 0, 0, 0 all through, but this is 512, and this is 999Q. So again, you divide both sides by 999. 999. So the whole of 999 cancels the whole of 999 up there, and then you have Q remaining on this side. The other side, we have 215 divided by 999. So you check whether there is a common number that can divide both of them. Just from the divisibility tests, divisibility test for 2, no. 3, no. Because the sum is 8. Sum is 8 actually, not divisible by 3. How about 6? No. You go to 8, no. 9, no. 11 also not possible. So that is the simplest. So you stop it there, and that is the fraction part of that mixed number. So it means then 3.215, a dot on top of 5 and a dot on top of 2 should be equal to 3, and 215 over 999. So that is how you go about it. Please don't forget, it's very easy to forget. Once you are done with getting the fraction part, remember to add the whole number part. So your entire decimal 3.215 with a dot on top of 2 and a dot on top of 5 should be equal to 3 and 215 over 999. So please don't forget. So again, we have this. So you will do the same thing. You'll just omit the whole number part. So let me use the fraction here to be a letter like m. So m should be equal to 0.256. So there is a dot on top of 5 and a dot on top of 6. So it means the pattern 56 is the one that is being repeated. So 256, 56, 56 being repeated. I've repeated it 3 times. So I'm having 7 digits in totals after the decimal point. So the rule is try and maintain the number of digits after the decimal point. So that is be able to help you compare the pattern after the decimal point. Because if the number of digits after the decimal point vary, then it will be very hard to compare that pattern after the decimal point. Because we need to compare and see whether we have 2 lines where the pattern of the decimal point is the same. So can you try and multiply by 10 both sides again? So you have again 10m should be equal to 2.56565655. I'm looking for 7. So 5656565. I'm omitting the last one, so I stop. You can see both lines, the pattern of the decimal point different. The first one starting with 2, this one starting with 5, so not even the same. So keep going. So 100m should be equal to 25.6565656. So that is still different, so continue. So 1000m should be equal to 256.565656. We have to maintain the number of digits after the decimal point to 7. So 5656565, but then you don't write the last 6, so you stop there. So you see this pattern here is the same as which one? Line number 2. So then you can subtract the 2. So I'm subtracting 10, and the other side I'm subtracting 2.5656565. So this is 0, 0. Remember, we are subtracting. So 0, 0, 0, 0, 0, 0. Here we get 4, 5, 2. And the other side is 0, 9, 9. So 990. So we will divide both sides by 990 here, by 990. So 990 divides 990, and the answer here is m. And the other side we have 254 over 990. So you see both numerator and numerator are divisible by 2. So you can simplify further. So we have 1, 5 divided by 2 is 2, remainder 1. Take it to 4 becomes 14. So divided by 2 is 7. And 990 divided by 2 is 4 because of 8, remainder 1, 19. 9 because of 18, remainder 1, 5. So 495. So 495. You check whether they can be divisible by 3, because now it's not divisible. They are not divisible by 2. They are not ending in even numbers. So you add 2 to 3 is 1 to 2 is 3, and 3 to 10. 3 to 7 is 10. So 1 plus 2 is 3. 3 plus 7 is 10. So 10 is not a multiple of 3. So no. 5, no. The numerator is not divisible by 5. 9, again, no. 9, for the number to be divisible by 9, the sum of the digits again must be a multiple of 9. 11, no. So you stop there. So that is the simplest form. So our fraction here is 127 over 495. So the fraction we are trying to convert to, the decimal we are trying to convert to fraction is there. So there is the whole number part that you must not omit. So you must not omit that part. So you rewrite. So 5.256 dot on top of 6 and dot on top of 5 should be equal to 127 over 495. So that is how you go about it. So that marks the end. There are questions here to help you practice. You can always attempt, post the responses in the comment section. You'll be able to look at them and give feedback accordingly. Otherwise, that is the end of the lesson. Goodbye.